The scale test is relatively simple in that it is simply a test in the classical sense. You can probably tell by the name what it does. Its main refinement is that it can test your particles on two different measurements of sizes. Let me quickly explain what I mean by this. The size of a particle is defined via its geometry creation operator, which you can see here. Shape. Now you can see you've got size here. And this parameter actually sets the size of the particle in world units, and you can see it's actually set to 0.6. Now the next parameter that we have here is scale, and scaling is a transform as in the rest of 3ds Max, and you can modify the scale value of a particle immediately after creation via this scale parameter here, or you can actually modify it using a scale operator. What you must remember is that the final size of the particle in any given integration step is a product of its original size, here, and is multiplied by the value of its current scale, which will be defined by this value here, or any subsequent scale operators. Now, let's have a look at how this is actually used inside this test. Let's go down to the scale test down here, and as you can see, we have a flyout here, which is the type flyout, and it has three options. So let's have a look at the bottom option, which is scale. This option is actually the default, and as I just mentioned, each particle is a scale factor on any given integration step. This option allows us to test for that current scale factor value, as it were. So remember, our equation for final size is final size equals the original size of the particle times the current scale factor. And this option is only testing for the current scale factor of that equation. So let's have a look at the next option, which is pre-scale size. This second option is also using one of the underlying values of that equation. In this case, the value we are testing against is original size value of our particle. This option will only produce a workable result if your particles were originally defined with differing sizes. In our example, to achieve this, I have split 50% of our particles and assign them a larger size value for us to test against. And I think you can actually see that's happening here. They're being sent out and given a different size value there. The last option is the post-scale size, and this option tests for the final size value in our equation. So in other words, it's looking for the resulting current scale of the particle, which is what you can actually see in the viewport. The next flyout is we have an axis order, and you can see you have a number of different options here. The average is the option that takes the three axis values, adds them all together, and then divides that value by 3, giving an average value. So this is an average scale or an average size for the particle. The minimum, this takes the smallest of the three axes and uses that as the value to test against. The median, in this case the middle value, is taken for the test value. This is not the same as the average. For instance, if you had x, y, z values of, let's say, 1, 3 and 20, the median value would be 3, as it's neither the smallest nor the largest value. It's actually the middle value of the 3. With the same values, the average, however, would be 8, as 1 plus 2 plus 20 is 23, and then we divide that by 3 for a value of 8, or near enough 8. Then we have, after median, we have maximum, and that is the largest of the three values from the three different axes, x, y, z. And then you have the choice of using explicit values. You can use the size or the scale of the x-axis, the y-axis, or the z-axis. So you can choose any one of those. We'll just leave it on average, which is the default. In the next group, you can see you have test true if particle value equals, and that is a choice between is the particle less than the test value, or is the particle greater than the test value. And obviously that depends on whether your particles are shrinking or whether they're expanding in size, and whether you want to test if the particle's reached a certain size on its way down when it's shrinking, or whether it's actually expanded to a certain size when it's increasing in scale. So you can actually choose which of the two options you have there. If you actually look at our test scene, you can see our particles as they're emitted are growing in size. So we're going to be using is greater than. We're testing for the particles for when they're actually greater than a certain value. In the next group we have size, and as you can see, the group beyond it, scale, is actually grayed out. So this is actually a toggle. If we have a look up here, we can see pre-scale size uses a